Welcome to A-Tech Training's Quick Start video series. Today we're going to be featuring Model 1820. This is one of our advanced electricity trainers. This is a state-of-the-art training unit that works in multiple configurations where you can use keypads for standalone operation or connect via laptop and have computer-based instruction. And meanwhile, everything can be recorded and all your students can key in their answers and their progress maintained utilizing our classroom management program. So if you want to go ahead and get your operations manual out, and let's get started. Let's focus in on pages 6 and 7 of your operations manual. There you're going to find two different configuration options. Option 1 is a setup utilizing laptops and computer-based instruction. Please see the previous video in this series for how to set up and utilize option number 1. For this video upload, we're going to focus on option 2, which is where our trainers are going to utilize our keypad as well as the 1820 unit. And then you can Ethernet them together to a Lantronix hub where all students' information and progress can be recorded utilizing an instructor PC and our classroom management software. If you'd like to know more about our classroom management software, please check out our other video series featuring Tony Salas, where he explains how to utilize the software and get all of your students set up and your classes built. So in the meantime, we're going to focus on standalone mode and utilizing the keypads. So let's get on over to the trainer and see what that looks like. The Model 1820 electronics trainer was designed with parts and pieces that replicate electronics that are found on today's modern vehicles. Starting over here on the left, you're going to find your battery where you have your positive and negative terminal post, followed up by a positive temperature coefficient circuit breaker, self-resetting. That way if there's any oopsies during the training process, this will go ahead and trip and cut the circuit and open it up, and then it will reset on its own once the PTC cools down. Following over here to the right, you have a variable potentiometer resistor, followed up by a photoresistor. Over here we have our relay. We have a light bulb over here on this side. Following down to this component, we have our LEDs along with some capacitors. Here we have a diode set that can be set up as a diode trio. Over here we have a regular pulse switch. Down below we have a bank of resistors of different values. Now we also have a Zener diode, and then the follow-up on the bottom we have 3 transistors of various sizes. So the courseware for this has developed a process to teach your students how each one of these components work, as well as engaging activities to let them diagnose and test their knowledge of the circuit. Before you can begin doing any student activities, you must get your trainer powered up and completely plugged in. The first step in that is going to be utilizing the supplied power source that plugs into the wall. It's going to come off to a simple plug like this that's going to go right into the back side of the trainer. Once that's plugged in, since we're using configuration number 2, we've got to get our keypad hooked up. It's very simple. You use the supplied Cat 5 cable, plug right into the back there. We're going to take that cable, and there are multiple ports on the back, but each one is labeled. There's 3 different ports, so it tells you there's one that actually says keypad, so you're going to plug that directly into that slot. Once everything's plugged in, there's a toggle switch here on the back. You're going to want to make sure to turn that on. There's a little red LED on the back to indicate that you have received power and your unit's ready to go. And this is, when you're using the keypad, the basic setup you need, so that way you can get started. So let's take a look at diagnosing some circuits. On our 1820 trainer today, we've got wired up a transistors basic circuit. To give you guys an idea of how this works, we can activate the circuit by flipping our toggle switch over. We notice that our light bulb comes on. We have a variable resistor here, which is going to be supplying our signal over to our transistor so that we can put power to the base, and then that will allow it to supply the ground, and then we can use this potentiometer to vary the intensity of the light bulb that's coming out. To give you an idea of how the keypad works, when you're in standalone mode, your keypad will immediately go to circuit number. So for this instance here, we're going to be working with circuit number 8. So we're going to punch in 8, and then every time we want to hit enter or move on to the next screen, we want to use the pound key. If we need to go back, we can use the star key. So I'm going to go ahead and press that, and then it's going to give us a couple different modes of operation here. If you want your students to just go through a random battery of faults, you can put the trainer in troubleshooting mode. If you want to use this trainer for final test out, final evaluation of your student's knowledge, then you can put it in test mode. There's also an instructor-only mode where you can do customized circuits and customized faults in a specific pattern. So let's check out troubleshooting mode. Remember, when we use troubleshooting mode, it just randomly inserts some faults in a non-specific order. So we're going to press 1, enter, and if we notice now our light bulb intensity has fell dramatically, and at this point we'll be able to go ahead and diagnose what's going on with the circuit. So I'm trying to troubleshoot here. Looks like we've got very limited operation. We definitely have got something failed in the circuit itself. If you notice on the trainer, all of the components are numbered. So our photocell here is 3, our potentiometer is 7, so on and so forth. So if we've made a decision and what the problem is, we have to start by telling the keypad exactly what component the problem is in. So let's say we think it's in the potentiometer itself. So we're going to punch in number 7, press pound. Then it's going to ask us what type of fault. So we can have an open, a short to ground, high resistance, short to voltage, or no fault. For example purposes, we're just going to go ahead and enter something random, or just say short to ground. Press pound. It's going to let us know if we got it right or wrong, and then it's going to tell us where the actual fault went into. So the real fault was at component number 5, and there was high resistance there. So if we look over here at our board, component number 5 is the light bulb itself. So if we were to isolate this component and run a resistance check, we're going to find that there's some unwanted resistance in the light bulb itself there. And in troubleshooting mode, all the students have to do is press the next key, then it's going to ask them if it wants to insert a new fault, and it's going to keep randomly generating faults for this board until it runs out of the pre-programmed faults that are for the specified circuit that you punched in the very beginning. So now we've got a basic rundown of how the keypad actually works and what the button process is and how to insert everything. Let's actually diagnose the circuit now. Using our transistor basic circuit, we're going to go ahead and insert a fault, which is going to cause some issues with our circuitry here. Everything's working fine like it's supposed to. We've got 12.64 volts as our source voltage, and I will give everyone a little tip. When you're doing available voltage or voltage drops, specifically available voltage, make sure you use the battery negative. That's going to help your diagnosis a lot. If you use the chassis ground down here when you're doing your available voltage, that could stub you up when you're doing diagnosis with our trainers. So everything's working just fine. Our switch is working well. We can deactivate or activate our circuit. We have some control over our circuit right here, so I can dim the light bulb. I can bring it back to full intensity. I'm going to go ahead and I'm going to use my keypad here, and I'm going to insert my fault. And we're going to watch, wow, all of a sudden we've got instant circuit failure. With that being said, let's go ahead. We know our source voltage is good. Let's do some diagnosis. Make sure that we've got everything we need to get our trainer operating properly. Let's see here. We've got 12 volts there. Got 12 volts there. Got 12 volts there. 12.5 volts there. So we're looking good as far as our power feed up to our circuit. And let's see here, we've got a direct wire that runs all the way across to our light bulb. So that should be hot all the way across there. And we've got 12.57. So that looks pretty good. What's going on down here behind the bulb? Well, we only got 0.067 left. So that tells me we've got pretty good voltage drop between these two pins, but we don't have a lot of intensity of our light bulb here. So I'm going to be a little suspicious that maybe there's something going on between these two pins, and in order to do that, I'm going to go ahead and deactivate the circuit. I'm going to isolate my component because I am suspicious that there might be some excessive resistance in here. I'm going to make sure I use my meter and change so that way I'm in the proper setting. Now that my component is isolated, I can do a proper resistance check. And if I look at that, I've got 106.5 ohms across the filament of the light bulb. So this is either to simulate corrosion in the connector, corrosion in the light bulb itself, but 106 ohms through a light bulb of this size is unacceptable. So with that being said, I'm going to go ahead and put in my answer because I think I've got it dialed in here. So here is my fault keypad. I'm going to go ahead and tell the keypad where the fault is, what component is it in, and it looks like we are component number 5 as our light bulb is indicated right here. So I'm going to press 5 and then pound, and then it's going to ask me what type of fault, and I found excessive resistance there, so I'm going to go ahead and press 3. Followed by pound again, and then the keypad itself, because I have it in instructor mode, locks the student out, and then the student will now have to call upon the instructor to come over and punch in their instructor code, which I'm going to pull off to the side so that way we don't share it with the world. And then for everyone, so that way everyone can see, it gives you a timetable of how long the student spent actually working on diagnosing the circuit. And then we hit pound, it'll keep moving us through the screen. It will then tell us what the correct answer was. It was component 5 with high resistance for circuit 8. The next screen will tell you what the student response was, which was component 5, which was high resistance, which means we did a pretty good job there. And then it's going to go ahead and bring us back to instructor mode. So this is a great way to just give single faults to students, but you can also get out of instructor mode completely. That's going to allow you to insert faults randomly. So I'm just going to power the circuit down and back up. It's going to give my screen a chance to restart here. In regular troubleshooting mode, random faults will be inserted. There's anywhere from about 2 to 8 faults per a pre-built circuit that is available in the courseware. In your operations manual, the instructor will have the ability to see where all the faults are and what components they exist in throughout the board here. If you don't want to use instructor mode, then the students will be launched directly into where they can punch in their circuit number, and transistor basics is circuit number 8. So insert that, and then they have the option to go directly in the troubleshooting mode. So if we press 1 there, then that's going to go ahead and insert faults into my system. And as we notice now, I've got nothing. I've got nothing right now. I've got no light bulb action. I've got no power going down here. And then the students can insert their answers just as we've shown before. So if we punch in a random answer, it'll let us know right or wrong, and then let us know what the correct answer was so we can keep moving forward. So these are really great trainers for challenging your students and actually testing their knowledge to see if they've learned something. Thank you for watching today's upload on our Quick Start video series featuring Model 1820, our advanced electrical trainer. If you've enjoyed this content or would like to know more about any of our other trainers, please go to atechtraining.com. If you click on the link at the top that says training, you can find future dates for our in-house training events where you can come to our location in Walton, Kentucky and learn more about our trainers and equipment. Please also check out our other social media platforms on Facebook and LinkedIn, and we'll see you next time.